Hello. Hi, good morning, everyone. My name is Aran, and we will wait maybe a few more minutes. And it looks like not everyone has joined us, so just be patient with us, okay? It is now the start. We will wait not more than 3 minutes, okay? Okay, I think we should start to respect the ones who are here on time. So good morning, everybody. My name is Eran. I'm from Ciklum. We're gonna spend the next hour, a little bit more than an hour, on a very hot topic of how you continue the move or prepare to move your testing from manual to automation. We have 3 speakers this morning. Myself, I run Ciklum regional activity in Israel, among other regions, and I'm based in Tel Aviv, in Ramat HaChayal, to those who know the place. We have with us 2 other speakers who will introduce themselves later on. Alex is our top QA guy and has been with us for many years. And he will take you through some of the journey. And then Lucy, she's a senior automation QA lady, and she's the master of all technical stuff that you're going to see later on. So I'm not going to go through all the details here, but we have, in principle, we have some introductions. We have some principles that Alex will cover, processes, and then we will have Lucy mostly focus on the quite technical aspects, including we're going to wrap up with a real-life, quite extensive real-life test automation framework. This will be an actual, not even demo, an actual technical show of an example. And then we'll talk a little bit about the future. Feel free to put questions on your, I think it's on your right. There's a question, or you can actually, for those who are comfortable, just put it in the chat. We will collect them, and Alex and Lucy will take care of, will address those questions towards the end. Okay. Some very, very few words for those who don't know Ciklum. Ciklum is a company that was founded in Ukraine, in Kiev, 18 years ago, grew organically without any major purchases to be big, 3,500 developers. We have management in London and shareholders in Denmark and New York. Quite international company. I'm not going to go into too many details about the high-level company stuff. I want to go deep. If you have any questions about any of those numbers here, just to point out one thing, we are very, very focused on companies that have very technical needs in terms of software R&D, core development, core testing automation, agile, etc. Few facts about Israel, since we are based in Israel, and most of the audience is from Israel. We have been here for 7 years, very successful. According to some people, we are the market leader. We have 70 clients. Most, if not all, are high-tech companies, some of the stars in Israeli high-tech. We have today approximately 700 software engineers, mostly in Ukraine, working for Israeli clients. Some of the names, for those who know, Sisense is a very famous, what they call unicorn. Payoneer is another unicorn. Those are big companies for high tech. WalkMe, very famous company. eToro. Anyone that wants details about these or want to talk to them about their experience with Ciklum, a lot of them have done testing automation work with us or manual testing with us. So feel free to shoot us some questions afterwards. Okay. Okay. Just a note: when we say Ciklum, we say 3,500 people. We wanted to show where the people are based. So we have 6 cities in Ukraine, and about 80% of our engineers are there. So we are very, very Ukraine-oriented company. We have one office in Belarus, quite big, in Minsk, 2 places in Poland, and 1 in Spain. The nerve center of the company and where Alex and Lucy are based is in Kiev. And we have developers spread over these 10 cities that you 10 hubs that you see here. I think that's it for the intro, and I think now we just need to dive into testing. Alex?
Hi, Aaron. Thank you. Thank you very much for the intro. And hi, everyone. I've been to Israel a few times before. I really like culture, country, and people, and the weather specifically. And but due to the COVID, we cannot make any physical conferences here in Tel Aviv on Israel. So we will be doing a series of webinars, and today we will be talking in details about test automation journey, about how to build a proper test automation framework if you don't have, or how to enhance, and how to scale it if you already have. So let's get started. A few words about me. I'm leading a cross-functional and cross-location quality engineering teams here at Ciklum, working for Ciklum for more than 8 years. And as Aaron mentioned, we have delivered test automation frameworks globally. And based on our experience, we know how to make it successful, how to make it scalable, and how to make it available for business owners and for the engineering teams. I have various uh, certification in this place, and I participated in the large number of the implementations and the supervisory of the delivery of their frameworks. Moving forward, before we start deep in dive into the slide and into our experience, let us share with you a quick poll. During the webinars, we will be asking with Lucy to answer on some of the questions to make it interactive and more valuable for you. What is the test automation start? Where you are starting? What test types would you cover first? On the right, you will see a polls, and we already published that. If you can take a look and answer on these questions, it will be available for our experience to share with you more relevant information and for your experience exchanging between participants. So I see some people applying to API, end-to-end UI starting. Okay. Let's give a few seconds, maybe 10 seconds more. So you will see the answers from the audience as well. Cool. 5 more seconds. Okay, good. So most top answer, as you see on the screen, we have API. So most of their participants here today would start from the API. Already started the integrations, a really small piece to answer end-to-end and the UI testing. Okay, good. Thank you very much for that. Let's deep in dive and let's share with you what is our experience when we see the client, when we see the engineering teams that do not have the test automation in place. What is a typical approach, how companies move from manual testing to test automation? You see in the beginning of the journey, or small or mid-sized company starting to scale, get an investment, and need to deliver the available product from the engineering perspective. So, and do not have no testing experience or no almost dedicated testing teams. Most of the such engineering teams and journey started from we do not have any testing capabilities. Let's investigate the application. Let's admit the bugs. Let's start doing exploratory testing. They do not know their test design techniques, how to optimize what technology use, etc. For example, we have for sure in various resources a lot of guides how to do that, but most of the companies do. Is this a first step that the companies start doing when they need to build the proper testing function and proper test automation? So exploratory testing. Then some of the companies understand, okay, and business asked, okay, what is the status of the build? What is the information? How many bugs you found? What is the speed of your regression test? Can you make it faster? Can you make it available? We need to release faster, etc., etc. So the companies and engineering teams start to do the structural manual testing. Okay, we have building the test scripts, building the test suits, components, different metrics around that. Then when the application is growing, the number of tests obviously is growing. And such engineering teams start having a lot of tests executed manually. It takes time for sure, from 30 minutes, 1 hour, few hours, few days, few weeks even. We've seen such companies that have hundreds or thousands manual tests, and they need to execute them against the different environments, different targets to make sure that the build that's released to the end users, to the productions, are stable and verified. Then, for example, for sure, the first test usually it's UI tests end to end or from acceptance perspective, because companies are focusing on their business value for the users, delivering the features. So the testing is done from a user perspective. So a lot of tests from this bunch of tests are UI tests, and they executed for sure manually. Then their regression suite can be completed on time, and engineering teams thinking, okay, how we can behave differently, how we can optimize the test execution, how we can embed the test automation. Someone decides inject test automation, someone from the team has different experience, etc., etc. And their first things usually that we see, as you see from the poll as well, some of the companies really start from the UI tests, from a different tests perspective and different focus of the tests. And some engineering teams start from the UI testing base. For sure, it's a little bit more painful, a little bit takes more time to do that. And during the webinar, we'll be showing components, how to start to build the tests from the API perspective and from the UI perspective, both embedded into the one framework. If you have a test automation in place, for example, you already start building that, how to quickly check in a few minutes time if your test automation bring values. Most of the engineering teams that we see on the market have some kind of some maturity, some kind of the implementation of the test automation framework. And how to check if the test automation is comprehensive from business and technical perspective. We prepared for you a really simple checklist. We will not deep dive into the details. The checklist will be delivered after the webinar for you, but just for your awareness, so you can check with your engineering team if they have a proper and mature test automation in place and what kind of the improvements can be done to make it more scalable, more available. You see on the left side on the screen, 10 questions related to a business and management perspective, and on the right screen, technology perspective. Let me give you an example. For example, the question, have you any calculated return on investment and continuously revise it for embedding test automation? Or do you have the proper test automation strategy in place and continuously updating that? For example, if you go through this checklist and ask for yes or no, you can get some score for you for review for your engineering teams. And for example, if your score is more than 80%, well done. You have only 20% in your backlog for improvements to make it more available. If your score will be from 30 to 80, you're doing the right things for sure, but more strategic activities, more fundamental activities should be done in place to make sure your test automation really brings value to business and to technical teams. And if your score is less than 30, might be you just started, might be you just learning how to embed test automation into the engineering teams. So the significant transformation is needed for your test automation approach and the frameworks and the tools. So during the webinar, we'll deep dive and show to you how to start it and how to build it from the beginning in a right way. So moving forward, as we announced it, we will discuss shortly what kind of their test automation capabilities you need to build when you start in your journey. For sure, some of their common frameworks and best technologies that you can find on the market, you need to know, or your engineering teams, you should have some skills related to, for example, Selenium WebDriver, how to interact with web mobile applications, how to build proper tests for the native hybrid and different types of applications that you might have. You need to know how to approach the API testing and API test automation from a REST SOAP architecture, if you have. From the technologies perspective, depends on your focus and your backend front-end technologies. You need to have the proper skills that have a knowledge how to build test automation for Java or for the Python, etc., etc. From the infrastructure perspective, you need to know how to run the test in a cloud environment, or you might use a virtualization, how to embed into CI/CD using Jenkins, Bamboo, TeamCity, or other tools. If you have a mobile applications, you need to know how to build your local device lab and how properly build the test, run the test, and receive the results from the mobile applications, from the mobile labs, etc., from in the cloud or local one. From the methodology perspective, more and more popular for some of the cases, BDD, TDD techniques, both together engineering teams trying to embed test automation, manual QAs, DevOps, developers try to understand and build these techniques. If you choose the BDD approach, for sure, it will be a different story and different approach how to build a proper test automation using BDD. From the capacity perspective, obviously, you should decide, would you like to have proper expertise and scale this expertise inside? It for sure it will take time to make it fundamental available, or you might ask your vendors or partners to help to bring the proper expertise to you, help to define everything that you need from the fundamentals perspective, and then help to build the proper scalable test automation framework, and then your teams can increase from a coverage perspective, etc. From the focus perspective, if you already have, if your departments is big or engineering teams, you might have various projects, various technology stacks, how to understand if different teams using a proper test automation tools and technologies, how you can reuse between the projects, such kind of the POCs, etc., etc. So you might need to build some automation implementation, automation support capability, some training between the teams, how to train new people or newcomers, how to train them, new technologies, etc. So those kind of the capabilities is really key if you would like to have a proper setup, engineering setup in place. And from the value perspective, you should constantly revise and understand from the audit and assessment perspective if your test automation from a technical perspective bringing value to product, to technical engineering teams, and to the business. This is just in short. For sure, we have much more larger experience how we are building test automation engineering teams, and we will be gladly sharing with you such experience on the separate webinars. Another poll that's already published, and I see already answers on that. In additional, what kind of the challenges in adopting test automation holds you off implementing test automation on your projects? For example, you can choose a multi-level answer, multi-choice answer, and I already see some of your answers, and we see, okay, no clear vision and strategy on where to start from. Another most popular answer, lack of time to build test automation. Okay, it's on the first, okay, and then three more answers, similar from a score perspective: lack of skills, fast changing requirements, and diverse. Okay, let us take 10 more seconds, and if you can answer using the poll mechanism, it would be good to understand your experience. What is the challenges you have right now in your engineering teams? Okay, good. Thank you for the answers so far. I see top two questions: lack of time to build test automation, and no clear vision and strategy. This is really good, and thank you for joining us today, because we will be sharing with you how to create valuable and not time-consuming test automation. So on real-time demo, so you will have at least understanding what kind of the components we need to build. So we'll cover the questions about the time to build test automation to bring the experience to you today. And from the vision and strategy where to start with, we already covered some of the part from the capabilities, and I will moving forward to the challenges as well, what we usually see during implementation. On this slide, this is a typical major challenges where we overcome or we are helping companies overcome to build the proper test automation in addition to lacking of time or skills or strategy. For example, we need to make sure that the application is ready for their test automation, that the component is testable, architecture on layers. This is a crucial part to make sure your test automation will bring value in the future. For example, I will not deep dive into each bullet points, but will be happy to answer on your questions. But I will be going through the major areas in orange on the screen you see. From implementation time, you need to understand and to put some metrics around the test, number of tests, parallelization, and how fast you need the answer for or feedback from your test automation test or frameworks. For example, what is your strategy for test design? What is your strategy for building the tests and running the tests? How you do test generation of data, etc., etc. From the execution time, how you build the dynamic test suites, for example, how you can run if you have, for example, 1,000 of components in your applications and only 10 components and change it. Does it make sense to run full test automation framework? Obviously not in full test. But how you can build the proper framework, trigger only those tests who are detached to these components, etc. How make it traceable between the components, test automation, and the test automation framework and the test itself. So a lot of challenges inside the execution time that can help to optimize and to deliver the fast feedbacks to the engineering teams and to make sure the product is stable before the releases. Result consumption, to make sure and embed the culture for the engineering teams about of the leveraging report that the test automation is producing, test results is produced, but the test automation for the products, developers, engineering teams overall, because obviously we've seen the situation that the engineers building the framework, consuming the results, and no one sees the results, and no one use the results for the decision making from a test automation. Obviously, this is their most related for culture, for the communication stuff of things, but obviously as well from a technical perspective, how to make the results traceable. Lucy will show to you today what kind of the reporting we are using, how it's traceable, how to understand if the tests are broken or the application is broken, and how to have all of the artifacts from the screenshots, video, and all of the steps after the test. From the root cause analysis, similar that I already shared with you, how to understand if it's a framework is broken or the test is broken, or how to understand where is actually a bug in which component, API, or the feature. We will be showing in a real-time demo as well this part about root cause analysis. And the maintenance. Obviously, engineering teams, if they are selected proper strategy, they're building it fast. Test of creation of the time for the creation of the test is really fast. But when you have 5 tests, everything is working. 100 tests, oh yeah, might be everything is working well. But when you have start your big application and scaling your features to the application, and you start having 500 tests, 1,000 tests, the time for maintenance usually for the not well-defined strategy for the maintenance takes time, even much more than the test for the creation. So this is type of the challenges we are usually helping clients and engineering teams to overcome. And after each bullet point, for sure, it's proper strategy and proper mechanism in place, how to apply the best practices to that. Moving forward from the building blocks perspective, this is one of the important principles that I would like to share with you, that never marry for one technology or one application or one tool set. You need to make the test automation framework as much as flexible from a component perspective, so you can easily change your reporting or a login or how you generate the test data, or if, for example, engineering team decide to switch to another CI/CD, how you quickly can embed the tests and the reporting there. So basically, or test management tool or integration with the Zephyr or test rail or another tools. So this is a principle that we usually suggest to follow, and what will show in your framework. You need to have uh, a lot of components independent but working together. This is a foundation for the test automation architecture that's you need to build proper from the beginning. And you see on the screen how many components you should develop or revise and connect to each other. So to make the framework architecture from the beginning workable and scalable for the future cases. And from the ROI perspective, we discussed a little bit of the technical part and strategy part. This is more relevant obviously for product for business teams. For example, as you see on the screen, different technologies used by applications bring to different ROIs. For example, if it's a standard Java application, web-based, etc., we can apply the regular stack. We know how to do that. And ROIs, return on investment, when you will see your product teams, your business will see from their embedded test automation, will be so huge. We received such number of percentage, you see on the screen, how much money we saved or time we saved embedding proper test automation for Java-based web applications. It's obviously less for the mobile application, so we just specifically showing this example to you, but still the ROIs, it's important part when you start building your test automation strategy, when you selecting your tool sets, for example, and test tools for the implementation. But still, test automation brings different value in terms of the time and money saved. And one of the last slide from myself, you see on the screen 5 levels test automation maturity. That's we referred from our experience from the standard TMMI model that you might find on the market, and we adapted that in Ciklum. Usually we oversee the engineering teams from 0 when they start doing, or they are in a starting point, and on their initial managed defined stages, we haven't less seen the engineering team that's on the measured or optimized stage. And specifically for this webinar, we will be showing to you how to build it from scratch. For example, if you're on 0 level, you're just on the starting point, or you have already some test automation in place, but you're not sure if it's the right architecture or right components or right reporting done, or your test automation bringing value, or how to scale your current setup, or how to transform to much more valuable. So for the initial managed and defined stages, when you already have some strategy, POCs, and tool selection done. From this perspective, one more poll from my end. What is your test automation maturity, referring to the presented model? For example, please share with us, or you are starting and you're on the 0 starting point, or you have some initial or defined approach for that, or you might already for the measured optimized approach, when everything is fully embedded and triggering and launching the tests after each commit, and even embedding some machine learning approach to that. So it would be interesting to see the results. Okay, so far so good. Most of you on a starting point, some of you on initial stage and on defined stage. I would say when you define some POCs and you're running that. Some of you on a measured stage. It's really great to see. Let's spend another 10 seconds. Please answer on the questions. It's interesting to see the results. Good. So top 2 answers, top 3 answers. I see top 2. It's on the starting. You are on the starting point, and it will be really available when we switch right now to the creating the framework from scratch and showing to you the component. Some of you on the defined stage, is really good that you have a defined approach, the tool stack, and you need to understand how to scale it, and might be how to improve some of the components. And some of you on the initial stage when you select it. It's really great. Thank you very much for the answers. And right now we will be switching to their design and test automation framework and make it scalable to Lucy. Lucy, you're on stage.
Yeah. Thank you, Alex. Thank you. So let's start our technical part of the webinar. So how to design test automation framework and make it scalable. Let me tell you a few words about myself. My name is Lyudmila Suslova. I'm a senior automation engineer in Ciklum Digital, and I have experience with test automation more than 5 years. I have delivered and created a lot of test automation frameworks for different purposes, and today I'm going to share some of my knowledge in terms of test automation and test automation framework creation. So let's start. Today, I want to talk with you about the test automation as a part of the QA process established on your project. I want to discuss several points of designing the framework from the very beginning to the end when we have a solid foundation for test script development. The demand for delivering quality software faster is a modern reality, and basically we can't ignore it. That's why product teams are in constant search of better technologies, methodologies, and approaches. Many teams have already adopted continuous integration, continuous delivery, DevOps practices, and test automation is the initial and common part of these aspects. One of the high priority questions that arise when you start thinking over the idea of building a test automation framework is what tool or set of tools or libraries, approaches to use. Test automation tool is a crucial component in the process of delivering benefits of automation to the product. And the current test automation trends have increased in applying of artificial intelligence and machine learning to offer some advanced capabilities, for example, for test optimization, intelligent test generation, execution, and of course, reporting. Among these tools, you might have heard about Catalan Studio or Test Complete or some similar tools. And moreover, such tools are designed for codeless test automation. Really, it sounds interesting, but I think it's not always a flawless solution. At this moment of time, I think it is near to impossible to create such test automation framework that does not require any coding skills and strong programming language knowledge, along with some test automation patterns and approaches. As for me, to create a reliable foundation for the whole test automation process is a major challenge to resolve. And also, we have one more poll here. So what would you rather choose? Build a test automation framework from scratch or some codeless test automation solution like Catalan or Test Complete? So please take another 10 seconds to answer this poll. Okay. And what is our winner? It is building test automation solution from scratch. Okay, here I agree with you. And now let's talk about the test automation framework in more details. Before designing any framework, you need to answer several questions, as Alex has already mentioned. So what is the problem you're solving with test automation? What do you want to achieve? Is it an integration into CI/CD process or the time reduction for regression testing, for example? Do you plan to include test automation results as another one quality gate for your product? That's very important questions. And also, do you understand the product and its needs? For me, it is very important because when you have a deep understanding in your product, you can design your testing, both manual and automation, precisely and more accurate. Then, can you foresee the future test automation needs? If you decided to start with test automation of the API layer, for example, would you extend your tests to cover the UI part as well? Or do you have ongoing mobile development, which should be also covered with automated scripts later? Then, do you already have the test infrastructure? Actually, this question should be asked first, as for me. Test infrastructure often imposes restrictions and limitations on tool selection and even on types of testing to be automated. And after having a clear vision on test automation process to be built, you can proceed to the next step. Now, I think we can consider the most common case. We've decided to create our own test automation framework. We need to cover API and UI layers, and we're going to use, let's say, Java stack for that. As for me, three major components of reliable test automation framework are flexibility, maintainability, and best practices. Framework should be flexible and extendable. It should not limit us. On the contrary, it should encourage us to adopt something new, to try to implement challenging tasks, and so on. Framework should not be rocket science. It should be as simple as possible, and any changes to the framework should be applied without any pain. And of course, test automation world does not stand still, and you need to be at the center of everything in this area. And I think I don't even need to say that the framework should embody all the best practices and ideas. And now, I want to give you a so-called tool selection guide. I started several frameworks from scratch and spent quite much time deciding what to choose, analyzed the available on market libraries. And now my goal is to save your time in future. And I'm going to give you a real-world test automation framework example so you can pull it from GitLab and start your test automation journey very quickly. So where is the starting point? Usually we start from a build tool. And right now in Java ecosystem, we have the selection between Maven and Gradle as a major build systems. And they have the pretty similar functionality, so I think it depends on the experience, on the test automation engineer experience, what to choose. But here I see the main disadvantage of Maven is its old school XML syntax. So sometimes it is very difficult to read all those huge POM XML files and find the right place, or maybe you haven't closed the tag or something like that and everything is broken. While Gradle build tool wins in flexibility, performance, user experience, and dependency management among other existing build systems, as for me. And moreover, Kotlin or Groovy scripts can be executed inside Gradle build files that allows us to incorporate some additional logic, of course, if required. So as for me, the top selection is Gradle here in our case, should be. And next, we move into the test runner. This is one of the most important parts in our test automation framework also. So the selection is pretty similar. We have basically two libraries here. It is JUnit and TestNG. And as for me, it is also a question of experience, what tool to choose. But now JUnit is one of the most popular unit testing frameworks in the Java ecosystem. The JUnit 5 version contains a number of exciting innovations with the goal to support new features of Java 8 and above, as well as enabling many different styles of testing. And JUnit 5 provides numerous features such as test factory for dynamic tests, nested tests, custom extensions, group assertions, and so on. So definitely we want to have it in our framework. And then when we defined these two main components of our test automation framework, we can move to the architecture and layers of the framework. And by the way, which components does your current test automation framework have? So you can answer it on the polls tab as well. So let's take another 10 seconds. Yeah, so here you can select multiple options here. Okay. So let's wait a couple of seconds so you can make your choice and vote. And now, who is the winner here? Of course, it is test runner, reporting. Some frameworks have login sections, static code analysis, and some of them it has integration with the DI, dependency injection tools, and even with some cloud system. That's great, but the winner is test runner at this point. Okay. So, and now I'm gonna share my screen and I'm gonna show you the real world test automation framework itself. Okay. Okay. So now you can see my IDE. Basically, I'm using IntelliJ IDEA. I think it is very comfortable and easy to use, and it provides a lot of capabilities for faster development, as for me. And let's consider our demo, our example. So the structure is common for any Java application. And as I said, we have already selected our build system. It is Gradle. So you can take a look how our configuration file looks like. So everything is clear. We see all the plugins that are incorporated in our framework. We see some additional configurations, and it is very easy to read. Also, in this Gradle build file, we store all the dependencies in this section, in dependencies section for our project. So they are very readable, highly readable here. And one of the cool features of Gradle is that we can create our custom Gradle tasks. So for example, you can see here run API test task and run UI test task. So these tasks were created by me. So I can make some filtering, test filtering inside these sections, and I can run my, for example, UI or API test just with one simple Gradle command. So it is very comfortable as for me. And of course, you can incorporate some additional logic. You can read some system properties here, as you can see on these lines. And also JUnit framework, testing framework, it allows us to use so-called test filtering. So there are a system of tags that can be set for different test methods or test classes, and we can easily filter all our tests and form, for example, some regression test suite, smoke test suite, or other test suite as required for our project. So let's move on. Here we have basically two packages. It is a standard in Java world. So it is main package and test package. As for me, I prefer to store all the test infrastructure in main package and all the test scripts, automated test scripts, in a test folder. So for me, it is quite clear where my tests are, and it helps in code readability, as for me, to store and structure our code in such a way. Of course, we have some resources for our application, test application. And in my case, in this case, I'm also using a Spring Boot 2 library, and it is kind of integrator for all the modules that I have in this application. So we can create such an application YAML file, for example, and in this file we can store different configuration parameters, some, for example, like browser, different URLs we use in our tests. So everything could be stored just in one place and can be managed from one place. So a little bit later, I'll show you how to use these properties inside your tests. And of course, we have some configurations for our JUnit platform. So here you can see the configuration, how to run our tests in parallel. So as for me, it is quite simple configuration. We can set the number of threads to be run, and we can define, for example, the strategy. It can be fixed or some other strategy. We can run our test classes or test methods in parallel, and we can define different relations between our parallel test execution. So, and as I said, everything is managed from one place. That is very comfortable for me. Okay, let's now consider our API layer infrastructure. So we will go inside main package, and what we see here, we have different separated packages for API tests infrastructure and UI test infrastructure. Of course, here you can see the application class. It is our Spring Boot application entry point. So it should be here. It contains only one made method because it is like an entry point of test application. Okay, let's move on to the API part. When we are talking about API testing, we need to think about the tool that we're going to use for API requests and responses, for API requests, for making calls and getting the responses from server. For Java world, I know that Rest Assured is quite popular, and basically I like this tool as well, and it provides a lot of features out of box, so it does not require any complicated setup or something like that, so you can just include it as a dependency into your project and start using it. Of course, you need to have some knowledge how to perform API testing and how to use this tool, but it is pretty easy to do that. But as for me, in this case, I'm using another tool. It is called Retrofit 2. Why I have chosen this tool? As for me, it gives a lot of flexibility to our API testing, and it has basically no limitations because it is not a framework. It is a pure type-safe Java HTTP client. So, and we can do everything we want using this tool. And to start using Retrofit, we need to take just 3 simple steps. What do we need to have? We need to have a service builder class. Okay, so let's take a look at this class. Basically here, what I have a generic build method. Why it is generic? Because we want to build different classes with endpoints. So to be flexible, we have this method to be generic. And here we are making some configuration of our HTTP client. It is OCHTTP3 used here under hood of Retrofit. And here we can make some additional configurations. It is very important, for example, in this part, when we set different kind of timeouts. We have read timeout, write timeout, and connect timeout. So our tests will wait some time till we will be connected to server and wait some time to get the response, because a Retrofit can work with even asynchronous requests. So we can make use of this. And of course, some connect timeout, it's a waiting time to connect to the server itself. Then in this section, we have a set of interceptors. What is interceptor? It is a retrofit mechanism that allows us to intercept request or the response. It is very useful and comfortable. For example, if we have requests, different endpoints, and they include one parameter, all of these endpoints include one parameter. For example, let me share this interceptor with you. So, for example, we need to add a language parameter to each and every our request. So what can we do? We can just manage it in one place, in one single place. So we don't need to modify and update all the requests, but we can just intercept this request and add the query parameter, build our request again, and proceed with it. So our request will be already modified and sent to server with including this language parameter. And of course, it is very comfortable, and I think it's very cool to use this feature, for example, with headers. As you know, API testing requires, when you construct some endpoints, I think in most of the cases, you need to send some headers to server in your request. So, for example, you have a content type, accept, and fetch mode headers, and they are the same for all your requests. So, of course, we can make use of retrofit interceptors and intercept our request, add all these headers, all required headers, and send an updated request to the server. And everything, as I said, is managed in one place. Okay, now let's get back to our service builder. So at this point, we have all our interceptors set up for our API client, and then we need to build the retrofit itself. So retrofit allows us, first of all, I want to point your attention on this line. So to have everything clear, what's going on in our test, it is very important to have a login system in your test automation framework. And this just 1 or 2 lines of code helps us to see all the logs, all requests, all parameters, all responses in the console. So it simplifies the debugging process very significantly. And we can, of course, we can control the level of our login to be performed. It can be very brief, some brief logs, or we can have the full information about all our requests and responses. Then basically we are setting the client to our retrofit instance and adding the converter factory. Retrofit allows us to convert the raw server responses to Java objects on the fly in the runtime. So it is really cool feature, and it is possible using this converter factory. In my case, I'm using a JSON library, and as you can see here, I'm building JSON here, and I'm adding this converter factory to the retrofit instance. So it makes possible to convert server responses to Java objects on the fly. And as for me, it is really cool thing, and it can be used in our API test automation. And one more point in this class I wanted to show you, it is this interceptor. It is Allure HTTP3 interceptor. It is used to gather all logs and publish them into our reporting system. In this project, I'm using Allure 2 for reporting system, and later I'll show you how it looks in the real live report. So, okay, now at this point we have our service builder class ready, and the next step we need to take is to create endpoints interface. Okay, so, and in this interface we can store all the calls, all the endpoints related, for example, for this or that microservice. In my case, I have kind of products endpoints. I have a product service, and I have product-related endpoints. So for me, such approach increases readability and of the code, and it is very easy to understand what kinds of endpoints do you have, and to what service are these endpoints are related. So it is very structured and stored in one single place. And of course, you may notice this annotation here, service host annotation. It is custom Java annotation, and it accepts two parameters. It is type and path. So as for me, it is very convenient mechanism to use this service host, because it gives us possibility to build our base URLs dynamically. What I mean, for example, we have an service type enum. We may have in our project different types of microservices. It can be login microservice, products microservice, checkout microservice, and so on. And all of these microservices can use different base URLs. For example, like in my example, we have microservice with this URL, and we have microservice 2 with another one, with another URL. And this approach helps us to manage all microservices endpoints, base URLs in one single place. So when we have, for example, this annotation, it says that we are going to use microservice type, and we are going to use exactly this base URL. And of course, we can specify some base paths here as well. And when we are building our endpoints class, this URL will be used dynamically, because we have one magic line here, just where we have our URL. So here we are building our base URL by creating retrofit instance, and we are reading this annotation. We are getting its type and base URL and service path. And in this way, our retrofit instance will be using different base URLs for different types of microservices. So, for example, if we have kind of login endpoints, we can just put a service host annotation here. Yeah, and we just need to specify its type. It's something like this. And we can also specify the path here. For example, something like this. We need to import our values, and it means that login endpoint will use another base URL than products endpoint. It is very simple, and it can be managed from one place, and moreover, it can be managed dynamically. It can be created dynamically. Okay, when we have our endpoints ready, also I want to pay attention that retrofit allows us to use so-called code blocks, so we can build our URLs with different parameters dynamically. So we can pass these parameters from our test script, and our endpoint will be updated with those passed parameters as well. And then what the third step we need to take to start using retrofit for API test automation is to actually build our endpoints class. And here I'm making use of Spring Boot as well. So I have, it is a service annotation, so it means it is a component in Spring context. And I have a post construct annotation. It is also a Spring Boot annotation. It allows us to add some features to previously constructed objects. So basically here we are building our products endpoints class, and we are ready to execute our requests and get the responses. So what I have here, I have two methods here to get all products and to get a product by code, for example. I pass some parameters as required for my endpoint, and I execute this request. So in this point, I'm gonna have the executed request and the raw response from the server. We can have some additional layer kind of steps for different services, because sometimes when we design our API tests, it is required to mix multiple endpoints in one test flow. And for example, if we have some repeatable actions, I think it's better to have some components that can integrate and incorporate all those steps, so we can use just these product steps from our test code, for example. As for me, it is a good approach to have everything separated. And now let me show you how the test script looks itself. So we go to the test package, open the API package, and let's take a look at the test itself. You can see here a lot of annotations, and someone can call it annotation-driven development, but nevertheless, all these annotations help us to build the good test infrastructure, internal test infrastructure. So the main component is here. It is a Spring Boot test as far as we are using Spring. So this annotation makes the Spring test context available within our test scripts. And as I said, JUnit 5 allows us to set different tags for our test classes or for our test method, as you can see here, for example. So this feature allows to filter our test scripts very easily. And of course, we can, in this test, we need to use some dependency injection provided by Spring Boot to auto-wire our product service. And we can use this product service inside our test. So, of course, we can have some additional settings like display name or severity. It is for, basically, it is for reporting system to have the big and clear picture of what is going on in our tests. So everything can be set on the test method level. And basically what we have here, we execute our request and get our response. So it is get all products. And then we are converting our response to the corresponding model. We have Java entity, Java product response class created, and we converted our response to this model. And then, of course, the main part of each and every test, it is an assertion. So we need to verify something. And in our case, we are verifying the product count. So how many of these products we have received from the server. And then we can go even deeper. We can check each and every product. So for example, we have a for each. We have a for each loop here. And inside we have an assertion, one more assertion as well. And in this test, we also making a request to the server and receiving the response. But in this case, we are expecting to get an error here. So we're constructing this error as an expected error, and then we make the request, get the response, convert it to the error model here, and make the group assertion. So group assertion is a new feature in JUnit 5 library. So basically, that's it. That's all the setup that you need to have to start to develop test automation scripts for API layer. So basically, you just need to have an HTTP client and kind of steps that should be used for your test flows. And basically, that's it. Now I think that we can move to the UI part. As I said, we have everything in one framework. Someone says that it's not very good to have everything in one place, to combine API and UI layers. But as for me, it can be very useful. For example, when you have some UI tests and you need to make some preconditions, for example, to create user or to get some information. And it can be easily done with the API call. So we can reuse our API functionality inside our UI tests. So it reduces code duplication and it makes our UI tests more stable because as far as you know, API tests are like more fundamental and they are much more stable than UI tests. And we can, of course, reduce UI test runtime using some preconditions with API calls. Okay, and basically I'll show you one example how API call can be reused in the UI test. But what's about UI? I think that when we are talking about UI test automation, the first thing you will recollect is Selenium WebDriver. And basically, yes, Selenium now it's kind of a golden standard in UI test automation. But in my case, I'm using Selenium driver wrapper called Selenite. As for me, this library is great because it allows us to concentrate on business logic and not on some WebDriver instance management or management of WebDriver weights or some asynchronous code weight. So we can just start our UI test automation in several simple steps. So let's consider this example. JUnit 5 has some kind of extension model, so it helps us to extend our test functionality. And we can make use of this feature, of course, and we can make our own extension. For example, a setup extension. Why do we need this? We need to make some pre-configuration of WebDriver instance and of our browsers before the test run. So it can be managed in one place. For example, with Spring Boot, we can read our properties. Do you remember I have shown you before this configuration file here? So here we have an URL and browser parameters. And in our setup extension, we are reading these values. It is very easy to do with Spring Boot, and we are ready to use these values inside our configuration. Then we are overriding before each method because we have our extension implements before each callback from JUnit 5 library. And here, basically, we have the main browser configuration. We can set timeout, browser URL, some capabilities, startup options, and all that necessary stuff. But just 1, 2, 3, 4, 5, 6 lines is enough to start UI test automation. And basically, I want to point your attention here on this line 39. Here, I'm adding a listener. It is for our reporting system. So all the steps from Selenide will be recorded, and we will be able to see them in our test report. So, and I will show you the report section a little bit later. And of course, we need to make some cleanup stuff like clearing browser cookies or some other necessary stuff for your website, for example. And of course, if it is not enough, this configuration, it can be extended, for example, with some browser capabilities. We can have, for example, an enum with different browsers we support and take these browsers from this enum. We can extend our capabilities if it is required and make more precise configuration of our browser. And also we can have something like a viewport if you want to run your tests, for example, against desktop, phone, or tablet versions. So everything can be stored here in one place. And of course, if we are talking about UI test automation, I think it is well known that it is very good to use kind of patterns. And in our case, it is a page object pattern. So maybe it will not be a page object itself. It can be a page component, a page fragment. I think it is very useful stuff because, for example, if you have several pages and each of these pages contain header and footer, so it is very convenient as for me to make separate fragments with a header fragment and footer fragment. And then we will be able to include these fragments in all our pages like just the fields. So in this way, we will reduce the code duplication and increase code readability, of course. As for me, in this example, I have 3 pages, and it is like small description of these pages. You can take a look at them, and basically it is standard page object. And of course, I have a common page. It is our like a base page, and it is inherited in all page objects, and it embeds all the common functionality for all those pages. And in my case, I have only one abstract generic method get here, so it can be overridden on our page object, for example, like here, and it simplifies navigation between pages inside your application. And of course, I have some helper, let's say it's helper class, that basically helps also to navigate between pages inside your application. That's it. I think that's it. That is required to start UI test automation. And now let's also take a look at one of the tests. For example, this one, homepage test. What I have here, as you can see, a lot of annotations as well as for API tests, because the structure is the same for both layers, API and UI. But here, what I have. At first, I need to register our JUnit 5 extension. So this will be executed as a setup before our test started. So in this section, we configure our web browser. And then, of course, as far as I want to reuse some API functionality in UI module, I need to auto-wire, include the dependency of our product service, for example. And what I'm doing here, in this, before each section, I'm making a request and getting the response from the server. So this part is completely reused from the API layer. And what I wanted to get here, I wanted to get here an expected size of our product. So how many products did server return us, and how many products do we see on our web page? So, and it is used as an expected value here. And of course, very tiny test, UI test. So I'm using a Selenide here, and as you see, there are some strange syntax, a little bit strange syntax if you were using a pure, clean Selenium WebDriver. But it means that I'm looking for an element, I'm clicking on it, then I'm looking for another element, I'm checking that it is visible, and moreover, Selenide has built-in assertions. For example, we can check if element is visible, enabled, and so on. And also, Selenide has embedded collection assertions. We can check, for example, size of the collection of elements. And in my case, I'm checking that my collection of elements should have size as I received from the API. So this is a basic scenario. And also I have as examples a couple of tests for other pages. And now I think it's time to run our test. Okay, so as I said in the beginning, Gradle allows us to create our custom Gradle tasks. So I created 2 tasks, separate tasks for API tests and UI tests. But if we want to run them all in one test run, we can do that. We just include this one, this task, and this task. And of course, we need to pass additional flag continue. It means that if there are some failures in one of these tasks, our test execution will not stop. It will be continued to the end. And let's try to, we can also, for example, include an info flag, and it means that we're gonna have very detailed logs in our console because we have set up our logger function for API module, and moreover, I'm using here a Solfa.j as the main logger for this project. So let's try to execute it. Oh, you see that our test started. It takes some time to build the project and to start everything. And as you see, we have really very, very detailed logs here. And for me, it is very good because it helps in debugging a lot. If you know what happened, and you can track that action, I don't know, till the line in your Java code. So, okay, so our UI test started. We are opening a website. And test is performing some steps, making some verification on these pages. And all these steps are recorded for our reporting system. Okay. Oh, a lot of logs. Yeah, we have a lot of logs because we have logged our requests and responses, and sometimes our responses are really big from the server, for example, some big nested JSON files, but nevertheless, all of them are logged, and we can check what was executed. Okay, the UI section is done, and now API test started. Okay, yeah, we see that something is going on inside our test. A lot of logs. Okay, and it's almost done, 91%. And yeah, we see that we have some test failures, so we need to check our report. So as for me, a reporting system is one of the crucial components of each and every test automation framework, because we need to give a feedback to our development team, to our QA engineers. We need to give feedback for our management team. So, and it is very important to have a good visualization of test automation results. So in this way, we can just take a look at the report and understand the current situation on the product with test automation. So, and I want to show you one magical line here. So this line will automatically generate a LU report after each and every test run. So you don't even need to make some manual actions here. So let's go to our build folder, report, LU report, and open in browser. Yeah, great. So basically it is a visual representation of our results. What we see here, on the main page, we see the general amount of test cases that were executed. And on the main page, we see the pass rate percentage. So in our case, it is just 50%. And you may notice that past tests are marked with green color, and we have some additional colors like red and yellow. And what does it mean? So basically, you can see these results in categories section. We have a product defects. We have a separation here for product defects and test defects. What it means? We can go inside suits section. We can take a look at all the steps that were taken in our tests. For example, we can go inside this API test, and as you can see, all tags sets in our test scripts are displayed here. Also, we can set some severity. We can see the duration of this test. So all necessary information is stored in one place. And of course, as I said, as far as we have a dedicated Allure interceptor, we can see our request here with all the headers. Even we have a curl here, so it's very easy to take it and execute somewhere else if it is required. And of course, we have the response here. So with all the headers and all additional information. And of course, we have our step that was taken in our test that converted our response to the required model. And if, for example, we have several requests, we have them all, request, response, so you can do something like that and see the JSON file that was received from the server. And now let's get back to our UI test. We see that one test is red. It means that there is a defect in our product. And of course, our reporting system helps us to get all logs and to see the root cause of our test failure. So what is it? The list size mismatched. So we expected 5 elements, but actually it was 4 elements. We can see all these elements also are displayed here in this section. And one of the very important features that we have a screenshot of our failed test. So it is marked, this step is marked with red. We can go inside and we can see the screenshot. So it is automatically embedded into our test report, and we do not need to take some additional actions to embed screenshots. And it is very comfortable and useful because really we can see just 4 elements, and basically we're checking these 4 tiles. We were expecting for 5 elements, but actually we see that there are 4 elements. And then we can analyze if it's a bug. We can create a corresponding bug in our test management system and proceed with it. And we have a yellow test case. What does it mean? It means that something wrong with our test automation framework. So it is not with the product itself, but some mistake, something wrong with our test script or the framework in general. And in this case, it identified that we have specified invalid selector. So we can see this step, and basically we can see this selector. So it is a products test. So we can go to the products test, and basically, yes, even our IDE helps us to identify such mistakes, and we can notice that there is something missing, and it's really missing. So in such way, it is very easy to debug what's wrong with our test automation or with the product itself. Also, I wanted to say a couple of words about this reporting system because I find it very useful not only for development team but for managerial team as well, because here we have so-called graphs section. It is a set of customizable widgets. So you can add some additional widgets depending on your product, for example, product needs, and everything can be integrated and displayed in this view. So basically we have the test automation status here, the pass rate displayed. We can divide our tests by severity. For example, this one is a critical test case and it is broken, and this one is also critical test case, but it has already passed successfully, and this broken test is kind of a minor test case. So everything can be tracked on this screen. Also, you can see kind of a duration widgets here, so it helps to keep automation in fit, if it's possible to say like this, because if you notice that some tests take a lot of time to execute, I think that we need to think over the test optimization, how to optimize our test flow, or maybe how to optimize our weights or something like that. And in this case, timeline section is very useful as well, because here we can see each and every test that was executed, and we can see it on a timeline. So we can, for example, select all tests with the duration about 11 seconds, and we have some information, additional information for analysis. So how can our test, for example, be improved if this duration time is very high, for example. And of course, Allure allows us to see some additional information. For example, if we have kind of history, it allows to store some history of test executions. And in this section, we're gonna see how many times test passed or failed or was broken. And also there is a retry section. So if we have implemented kind of retry mechanism for failed tests, we can track all the retries in this section as well. But as for me, it is a very lightweight, easy to set up solution, and it represents our test results very well. So basically, that's it. That should be done to start your test automation journey very quickly. So all these tools and all these approaches does not require any complex setup, and you don't need to spend a lot of time on tool selection and to create such test automation framework. And moreover, you can just pull this framework from GitLab, for example, and adjust it a little bit and start, of course, your test automation journey in API and UI test automation. So thank you for attention.
Thank you very much.
Thank you very much. So we are moving forward. We need to show only one slide as a summing up, and then we will quickly will be answering on all of your questions that you have listed into the chat. Thank you for the question very much. Just shortly answering your different. You asked different questions around why we need to choose this component and that. Just quickly answering on most of them. That's our principle to show to you that's how to build the scalable framework where each component can be changed to another one, and you do not need to redevelop full framework and everything. But we will deep dive into the question and answer that. And Lucy is showing a slide where you can download this QR code on the Ciklum GitLab. I already answered in the chat, so you can go to that direct link, directly download the code and adjust it and use it. If any questions for the code, you might refer to ask Ciklum help. So summing up for today, what we have? We have here at Ciklum in place award-winning QA practice. On the screen, you can see that we have a different experience in different business domains and different case studies. Previously, I showed the ROIs of the implementation of the different framework. You can see there, for example, we help to develop the scalable test automation framework for the business intelligence platform, and we help save the client up to 30% in testing time for QA transformation. Also, we have helped a huge amount of money for the large US corporate big enterprise that we developed application, managed to save money to building the proper test results, execution, test design, and everything related to that, and delivering the projects and helping engineering teams, development teams to deliver projects in time. The last one slide that I would like to show to you. Some of you answered on the poll where you are on the test maturity on like desired or optimal. Here is their, I would say, their ideal situation when you have the test automation is fully embedded into the software development lifecycle. You see on the screen one of the reference from a recent project delivered where we managed to have full execution of the various tests, test automation, load performance, security part of that within the 30 minutes, using their parallelization, using the cloud framework integration, etc., etc. It's much more here to say where you have number of tests of thousands of tests and you need to execute them in parallel. So we might deliver to you in a coming months a separate webinar showing on the advanced part of how of scaling of the test automation and embedding into the process, into development process and releasing process, etc. And right now the question for Q&As and a few summing up questions. As I already shared with you, never married to only one of the tools of the frameworks. You should build the test architecture and the process scalable plus changeable for any other tools. Always have test automation strategy in place, fully integrate test automation to the software development lifecycle that I already shown to you, because result consumption should be used by all engineering teams, and connect your technical solution to business drivers. And finally, ask Ciklum if you have any challenges with the process, with the test automation itself, or with any components that we showed today. And the question is, moving forward to our Q&A sessions, I already answered to some of them, but let's see on the question from the question chat about the test automation recommendation of the pool. Sending to you the answer right now. That's our suggestions will be to start with the API tests and to build on top of them any other tests like end-to-end UI, load performance, security, or develop them in parallel. But your journey should be started from the API test and the UI built on top of that. The next question from Boaz, what is their Grundle? It's question Lucy, maybe you can cover it shortly.
Gradle.
Yes.
Yeah, okay. So Gradle is a build tool. So basically in today we had an overview of a Java ecosystem. So of course I saw different questions about programming language selection, but it is kind of different topic. So today we concentrated on Java ecosystem, and in this ecosystem we have basically the selection between two build systems. So it is a system that built the whole our project, where we store all the project dependencies, where we store all the project plugins, where we manage all the dependencies versions, and where we define our testing tasks. So Gradle, it is a such system. It is widely used for Android development, for example, and it is highly integrated inside Android development. But it is also nowadays very widespread in common Java application development. So it is kind of system that integrates the whole our project and build it.
Great, thank you. The next question from Miguel, why Java instead of Python? Maybe I will be covering that. As we shared that you need to build the capabilities that's required for your technology stack. As a test automation practice at Ciklum, we have a various experience with Java, JavaScript, Python, C#. So just for the purpose, for the demonstration, for sure, we showed for you there, as Lucia mentioned, the Java ecosystem and tool related to that. But for your technology stack, for sure, another language can be selected for the automation. And our recommendation to put and use a language as much as close to your development engineering team knowledge. For example, if you are using JavaScript on the front end, let's use JavaScript on the front end, or Protractor, for example, for test automation, etc., etc. The next question, why Selenium instead Cypress? Next question from Miguel. Lucy, maybe you could cover it shortly.
Yeah, Cypress, as far as I know, it is a JavaScript tool, so it relates to another ecosystem, and In my case, I was using Selenium WebDriver, but it was wrapped into the Selenite library. It is also this Selenite library has different implementations. As far as I know, it has implementation for Python and maybe for JavaScript. It is ported as well. But for Java stack, I think it is very good solution to reduce everything unnecessary regarding management of WebDriver, Selenium WebDriver, and concentrate, as I already said, on the business logic creation and test script design.
Yeah, absolutely. Thank you. The next question from John Barbara: why Jenkins over GitLab?
It is a kind of philosophical questions, because each team selects CI/CD for its needs, and of course we need to analyze what infrastructure do we have and how it can be integrated. So I think it's kind of question maybe of experience as well. So if the team has experience with GitLab CI, so it can be easily used. But as for test automation, as for me, regarding my experience, so Jenkins is better to use because it allows much more capabilities for test automation, while GitLab has limited capabilities for test automation purposes.
Yeah, great. And the last question from Sam about what is the link to download. We already answered. We'll be sharing the presentation after in the follow-up pack. You will see the barcode there as well. We'll share the direct link on the Ciklum GitLab GitHub, where you will be able to download the link as well. And another one question before the end, can we use this to test microservices? Lucy?
Yeah, sure. This framework, the API layer of this framework was designed for microservices. So that's why I've explained how it is easy to manage, for example, different base URLs for each and every microservice, and how it is very easy and transparently stored, for example, all endpoints related to this or that microservice. So yes, this framework is good match for microservice testing.
Great, thank you. So everyone, you have 1 minute to shoot a few last questions. If you would like to ask anything else on top what is already asked. So let us use another 1 minute for doing that. If we will not have any question, thank you very much for the webinar. We shared with you, from my perspective, the test automation journey, challenges, capabilities. We are doing that for the last 8 years, and we are knowing the ecosystem and how to build proper ecosystem for different technology stacks. This is important. The business part and technological part of the while you're entering the test automation journey. And we showed to you today the live sessions. You will be able to receive the framework. You will be able to see the results. You will be able to use the framework. If any questions, to reach Ciklum, that we can help you to configure the framework or use the framework for your environment.
Okay. And with that, I want to thank everyone that showed up today, this morning. It was a pleasure having you. We will have other webinars. We will try to do once a month, maybe once every 2 months, on various subjects. And keep in touch with us. Feel free to shoot us an email or message of your future needs, of seminars, etc. And have a great day. Thank you very much, Alex and Lucy. Bye-bye.
Thank you very much, Sharon.
Thank you
very much, everyone.
Bye.
Have a good day. Bye.
Bye-bye.
Oh,